I welcome you again to the wonderful world of routing. Here we implement all the routing protocols discussed in part 1. That is, implementation of static routing, RIP, Igrp and Ospf. In these implementation we use multiple routers. Do concentrate on router name and the mode where each command is executed. Let's begin with router A. User mode, privileged mode, global configuration mode, interface E0, assigning IP address to E0, no shutdown, exit, entering serial 0, assigning IP address to it, no shutdown. By default, all interfaces are shut down. We enable any interfaces by using no shutdown command. Exit. Here is static route command. IP route 30.0.0.0 is destination network, 255.0.0.0 is its subnet mask, and 20.0.0.2 is next hop address. Now let's see the IP address and the status of each interface of the router. Show IP interface brief is the command used. Now we have completed configuring router A. Now let's start configuring router B for static routing. Router B user mode, privileged mode. Now global configuration mode. Interface E0, assigning IP address to it. No shutdown. Exit. Interface S0, assigning IP address to it. No shutdown. Clock rate of 64,000. Configuring static route as before. Exit. Now we have completed configuring both router A and router B. Now let's test its connectivity. Let's ping 30 network from router A. The ping is successful. Now let's move on to router B. Let's ping 10 network from router B. The ping is successful. This completes static routing. Routing Information Protocol or RIP is one of the simplest protocols. Let's configure RIP or Routing Information Protocol on both the routers. Router A. Enable privileged mode. Show running config. Let's check the IP address and various running configuration of router A. The IP route command shows that there is already a static route. The show IP route command displays the current status of the routing table. The S letter indicates the presence of a static route. Let's remove the static route by use of no IP route command. Let's check the routing table again. There is no S, which indicates there is no static route. Let's remove the static route on the router B now. Show IP route. Configure terminal. No IP route. Exit. Show IP route. Now there is no static route on both router A and router B. Router rip. This command turns on the RIP protocol on router B. Network 20.0.0.0. Network 30.0.0.0. These network statements tell the rep what networks to advertise. Now let's move on to router A. Router rip. This turns on RIP protocol on router A. Network 10.0.0.0 and 20.0.0.0. Exit. Exit. Show IP route. The R indicates RIP protocol. Ping 30.0.0.1. The ping is successful. And from router B, ping 10.0.0.1. The ping is successful. Similarly, show IP route on router B shows the use of RIP protocol. This completes RIP protocol. Now let's move on to IGRP protocol. No router rip. Turns off the rip protocol on router B. We can see that there is no RIP protocol. Now the pings are not successful because there is no routing protocol. This completes RIP protocol. Let's start IGRP protocol. Router IGRP 111. 111 is the autonomous system number. It may range from 1 to 65,535. A very large network is difficult to manage. Hence, the network is divided into autonomous systems and are numbered. It is also done to manage the network and for administrative convenience. Network 10.0.0.0 and network 20.0.0.0. At router B, router IGRP 111, network 20.0.0.0 and network 30.0.0.0. The show IP route command displays the presence of IGRP route. Show IP route on router B and show IP route on router A displays the use of IGRP protocol. The ping to 30 network from router A is successful. And ping to 10 network from router B is successful. This completes IGRP protocol. OSPF protocol. OSPF is the most widely used protocol. Let's configure OSPF on router A and router B. Router A, privileged mode, global config mode. Router OSPF 123. Here 123 is process ID. Process ID can range from 1 to 65,535. Ten dot 0.0.0 is network ID. 0.255.255.255 is the wildcard mask. 0 is the area number. Similarly for network 20. Similarly, configuring router B, router Ospf 321, network commands as before. Show IP route for router B, show IP route for router A. We can see the O, which stands for OSPF protocol. Ping 3 network from router A, ping 10 network from router B. Both are successful. This completes OSPF routing protocol. Finally, we are done. Feel free to send your questions. You can contact me at networking@theashwin.com. Thank you and goodbye.